Welcome to Geometry with Mr. G. Today we're talking about proving statements about angles, lesson 2.5, 2.6. So, starting with our first given and conjecture, we have B is between A and C, and A, B, and C are collinear, which we know that means they're on the same line. So we have segment A, AB. We have segment BC, right? So we have A plus BC. You should be thinking part plus part when you see that equals the whole, right? So this is part plus part equals whole. And the reason name for this is segment, we can say definition of segment addition. Segment addition. That's the first one. Cool. Let's look at the second one. So on the second one, we've got B is the midpoint of AC. So if B is the midpoint, we know for a fact that we can add hash marks here and here, right? That means they're congruent and they're equal, hence the reason why they're both 5. So this is like saying part equals part for this type of problem. So we can say segment AB is congruent to segment BC. And we can say that by the definition of midpoints. Again, if B is the midpoint, then we know by definition of midpoint, AB is congruent to BC. The third one, we've got, let's use red. Yep. M is between angle ARC. So we have the measure of angle ARM. So it's going to be this angle here. So we have measure of angle ARM. That's our first part, first angle. Second one, measure of angle CRM. So C to R to M will be that one. And then we have equals the measure of angle ARC. So ARC, which is the whole, right? So you should be thinking, again, this is a part plus part equals whole type of ordeal here. And we know that this is the case, or that this is true by definition of not segment addition, but this time angle addition, right? Because we're adding angles this time. Cool. Moving on to the next one, we've got ray MR bisects angle ARC. So we're saying the ray is bisecting the angle. Here's your ray, which means we know we can add hash mark, or the arcs, right? That's why the arcs are in here. Arc here, arc there. And the arcs tell us that the two parts are equal. So part equals part is what you should be thinking here. And again, we can say that because of the definition of an angle bisector. So definition of angle bisector. Awesome. Moving on here, we've got, says segment AB is congruent to segment CD, which means that if they're congruent, we know that they're the same in length, right? So we can also say AB equals CD. We can say, well, we know they're congruent, right? Add your hash marks, which means they're also equal in length. You can say that by definition of segment congruence, or definition of segment, congruent segments. Actually, I like that better. Let's do definition of congruent segments. We may shorthand that in the future to definition of congruence. You'll see that from us. Okay, and then the next one is almost the exact same thing. It says angle, and this time it says segments from angles. Angle ABC is congruent to angle DEF. Well, we know that if two angles are congruent, that means the measures of those angles are also equal, right? So we can say, you can put an arc in here, you can put an arc in here. You can say, well, if the angles are congruent, then the angles are also equal by definition of congruent angles. Awesome. Cool. Almost done with this first page. Now we've got line segment DB and segment AC are perpendicular. And we should know definition of perpendicular already, but if two things are perpendicular, then when they intersect, they're going to create a right angle. So we know that all of these angles should be right angles if those are perpendicular lines, right? So we can say if DB and segment AC are perpendicular, then angle DBC is a right angle by definition of perpendicular lines, right? That's just the definition of perpendicular lines. Cool. Okay, then we've got angle DBC angle DBC is a right angle, and we know what a right angle is, right? If it's a right angle, then that means the measure of angle DBC has to be 90 degrees, right? So again, this is our statement here. It's a right angle, or it's the given. So the conjecture, the conclusion that we can make is that the angle it measures 90 degrees. So this is true by the definition of right angle, right? Just the definition of a right angle. Awesome. Cool. If I look at the next one, right, these are pretty simple, and we know most of these already. Should be kind of a review for us. We've got angle 1 and angle 2 are supplementary. We know that supplementary means 180, right? They add up to 180 degrees. So that means the measure of angle 1 plus the measure of angle 2 equals 180, right? If I do angle 1 plus angle 2, right, the whole thing's going to be 180. So this is like saying part plus part equals 180. So if two angles are supplementary, that's the given, then that means we know they have to add up to 180. So that is the definition of supplementary angles. So definition of supplementary angles. Awesome. And then last but not least on this page, we've got angle ARM and angle CRM are complementary angles, right? Complementary. You should be thinking 90 degrees when you see complementary. So we got the measure of angle ARM plus the measure of angle CRM equals 90. And we know it's 90 because if you look at the whole, when you add these two angles together, right, this whole angle, you see the box in there, is 90 degrees. So this is like saying part plus part equals 90. So again, we can say if they're complementary, if the two angles are complementary, then they must add up to 90. We can say that because of the definition of complementary angles. And there's your first page. Now, a lot of reasons why we're doing this. If you're wondering why we're writing all these definitions here, you're going to be using a lot of these definitions here on the left side from when we are doing our two-column proofs on angles, which is on the next page. So on to the second page here, we've got number 1. It says, you reflect the beam of a desk lamp off of a mirror lying flat on your desk. Determine whether the measure of angle DBA is equal to the measure of angle EBC. Right, measure of angle DBA is equal to measure of angle EBC. Okay, cool. So we started proofs in the prior lesson, so we should be familiar with some of the basics of proofs. For example, we should be familiar with whatever it is in the proof, right? Whatever it is we're trying to prove should always be our last statement, right? That should always be the last thing in our statements column. Good. Whatever it is we are trying to, whatever it is we are given, right? Whatever the given is, should be our first statement. That should be the first statement in our statements column, which means our first reason for every two-column proof will always be given. That would always be your first reason for every two-column proof. Now, it's our job to use the picture and use the definitions we talked about on the first page to identify the reasons for 2, 3, 4, and 5. So let's think about it. Look at statement 2. It says the measure of angle DBA. So if I'm looking at DBA, we've got DB. Oh, sorry, that was wrong. Let me see. I was highlighting DBE. Here we go. DBA looks like this. And it says it's equal to the measure of angle 3 plus the measure of angle 2. Let's see if that's right. So I've got measure of angle 3 in here. Okay, that fits. Yeah, I agree with that. And then the measure of angle 2. Let's see, measure of angle 2. Well, angle 2 is this. And I agree, right? That's essentially saying part plus part equals whole, where the whole is DBA, right? So again, if you look at our reasons page, we said part plus part equals whole. It's the same thing as saying definition of angle addition, right? So I'll put, for shorthand, I'll just put angle addition. And that's okay, right? Angle addition, definition, angle addition. I know we all know what you mean when you say that. Same thing. Okay, cool. So let's look at number 3 then. Statement 3 says that the measure of angle DBA, which is the same from above, equals the measure of angle 1 plus the measure of angle 2. Okay, so this one's not as obvious. You have to use some clues. I would look at the prior statements that you have here. You see here that from here to here, this stayed the same. From here to here, this stayed the same. The only thing that changes is the measure of angle 3 becomes the measure of angle 1. So you have to ask yourself, why are we able to do that? And you should look up here. We've already defined, or we've already declared that the measure of angle 1 is equal to the measure of angle 3, which means anywhere we see the measure of angle 3, we can replace it or turn it into, right, the measure of angle 1. We can replace those. And so replacement, you should be thinking replace, that's another word for substitution. So we use the substitution property here. Okay, let's look at statement 4. Then we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle EBC. And this is our first time seeing EBC in this problem. So since this is our first time seeing EBC here, what I'm going to do is I'm going to go over here to our picture. I'm going to erase our prior colors. I'm just going to color that just to see, because it might be angle addition again. So let's take a look here. Let's color measure of angle 1 in red. Why not? So I'll color that. And then we'll color angle 2 in blue. And the question is, when I add those two angles together, is the whole going to be EBC? Well, let's see. Let's trace it. So E to B to C. Does that include angle 1 and angle 2? And the answer is yes. So again, this is indeed angle addition again. And that's okay. You can have the same reason more than once. So angle addition would be your reason here. And then last but not least, we've got statement number 5. How do we get from statement 4 to statement 5, right? So for this example, we do have to use some of the prior statements to help us here. Because you see here, these stay the same, right? Those stay the same. But then somehow the measure of angle 1 plus the measure of angle 2 becomes the measure of angle DBA. So how does this change? Why is this changing, right? Well, if you go back up here and look, let's look at statements 3 and 4, right? If you remember talking about the transitive property, should be from last lesson. Transitive property says that we eliminate whatever is the same from these two statements. So for example, the measure of angle 1 plus the measure of angle 2 is mentioned in both statements. So I'm going to eliminate that or cross that out, right? And you combine what's left. And what's left? Well, measure of angle DBA is equal to the measure of angle EBC. So by transitive property, we can say this. So we'll just put transitive. Okay, looking at number 2, the given is angle AEB is a complement of angle BEC. So again, our given statement is always our first statement. So that's why you see this here, first statement. And then whatever it is we're trying to prove will always be your last statement, right? Just making sure we remember that and continue to do that process. Our first reason is always given, as you can see here, right? Just making sure we remember those simple things. And we can actually add something to this picture because it says that angle AEB is a complement of angle BEC. We know, or we should know, that if those are complements of each other, that this whole angle AEB plus BEC, right, this whole side here, should add up to equal 90 degrees because that's what it means for them to be complements of each other, right? Complementary angles add up to 90. Good. Let's move on here then. So we've got our given statement. AEB is a complement of BEC. And then our statement 2 is blank, right? So you might be thinking, well, how do we figure out statement 2? Well, we need to use reason to right here. That's going to be our clue. That's going to help us figure this out. So it says definition of complementary angles. Definition of complementary angles. Well, we know that if angle AEB is a complement of angle BEC, then we know that the measure of angle AEB plus the measure of angle BEC, right? When you add these two angles together, what does it mean to be complementary? It means they add up to equal 90 degrees, right? So that's what is going to go there in statement 2. Now I'm looking at statement 3, and it says the measure of angle AEC equals AEB plus BEC, right? So then how do we know this, right? How do we know AEC is equal to AEB plus BEC? Kind of came out of nowhere, right? So let's go back at the picture real quick. I'm going to highlight this. So AEC is that angle. Hope you agree. And then the next one is AEB. So A to E to B is that angle. I'll color that in red. And then I'll do BEC in green. So BEC. So what you can see here is the AEC, the blue angle, right? The blue thing is the whole, right? It's including the red and the green angle. So this is actually a part plus part equals whole for angle. So we would say angle addition, right? We got this by doing angle addition. Awesome. Then we got 3 to 4, right? We go from measure of angle AEC equals AEB plus BEC to statement 4, which says the measure of angle AEC is now 90. So something happened here. It looks like it's some kind of substitution or transitive. So let's take a look here, right? From here to here, it stayed the same. But somehow, this whole piece here becomes 90 degrees, right? So I'm looking at statements 2 and 3. I'm going to look at some of the prior information here. And again, we should be thinking, we should be looking for either substitution or transitive here. And what I notice is, well, 2 and 3 both mention AEB and BEC. So if I do transitive and I eliminate AEB and BEC, right, eliminate whatever's the same, we can combine what's left, right? What's left? Well, what's left is the measure of angle AEC equals 90 degrees. So that is how we get statement 4 by using the transitive property. So my reason would be transitive here, right? Good. Then we got statement 5, which was filled in for us. It says AED plus AEC equals 180, right? So it's a straight angle. We know that because if one side's 90, then the other side has to be 90, right? If I'm looking at the picture up here, they both have to be 90 degrees, so that's 180. That's the definition of supplementary angles. And then we've got reason 6, but we don't have statement 6. It says substitution property. So something's being substituted here. In order to figure out what's being substituted, the easiest way to do that is to ask yourself what has been declared, right? For example, have we declared AED equal to anything prior to this, right? I don't see AED ever but prior to this. So we know it's not this being substituted. So I'm going to leave AED alone. Right, and then I see AEC. Have we declared what the measure of angle AEC equals? You should be looking right here and thinking, oh yeah, angle AEC is 90 degrees. So I can use substitution here and replace the measure of angle AEC with 90. All right, it's going to be 90 there. And then equals 180 degrees. So that is statement 6 with our substitution. And then we look at the last one. It says, how do we go from statement 6 to statement 7? Hopefully, it should be easy to see what happened, right? The 180 turned into 90, and we lost the 90 on this side. So what they're doing is they're subtracting 90 from both sides. So this is the subtraction property. Subtraction, and that is the end of that one. And the last problem, we've got given that angle 1 is a complement of angle 2, and then we've got another given, right? We have two givens here. We have given here and a given here, right? Angle 2 is congruent to angle 3. So these will be your first two statements, here and here, right? Those are our first two statements here. And then we have, I guess I should be careful. They don't always have to be the first two statements. It could be in another order, but that is where our current givens are. And then we have, remember, whatever it is we're trying to prove will always be our last statement, okay? Making sure we understand that. So let's look at our reasons then. We have angle 1 is a complement of angle 2. That's our first statement, and the reason is given, right? Our first reason will always be given. And then the next statement says angle 2 is congruent to angle 3. Well, again, we got that from the given, right? So again, the reason here would be given. And yes, you can have more than one given in a proof. And you can have them back to back. That's not a problem. So that's our first reason. Then we look at reason number 3, because that's a blank one, right? So we say, how do we get from statement 2 to statement 3? Why can we say that the measure of angle 1 plus the measure of angle 2 equals 90? Why are we able to say that? Well, we're able to say that because if you look here, back at statement 1, we said that angle 1 and angle 2 are complements of each other. That means they're complementary. And by definition of complementary, that means they add up to 90 degrees. So I just gave you the answer there, definition of complementary angles, right? Definition of complementary angles. All right, good. Moving on. Then it says definition of congruent angles, right? Because if, that's going from 2 to 3, right? So for example, let me explain this. If statement 2 says that the angles are congruent, well, by definition of congruence, if they're congruent, that means they are also equal. So that's why we did that. All right, statement 5 is blank, but this is our clue. We know that the substitution property is being used, right? Something is being substituted. Something's being substituted, right? So what I'm going to look at here is I'm going to say, okay, well, it's probably being substituted from this one. And the only reason I know that is because the measure of angle 2 and the measure of angle 3 have not been mentioned anywhere else, right? But what I can do is say, well, I know the measure of angle 1 I can write here. That hasn't been mentioned anywhere else. Plus Measure of angle 2 has been mentioned in two spots, hasn't it? Here and here, right? So the measure of angle 2 is equal to the measure of angle 3, which means we can replace this measure of angle 2 with measure of angle 3 equal to 90 degrees. So there's our substitution property. And then last but not least, we get to our, well, if these two, change color here. If these two angles on statement 5, if they add up to equal 90, then we know that if they add up to 90, they have to be complements of each other, right? By definition of, again, complementary angles. And that is today's video.